Today, we're going to be talking about something that's pretty hot right now. We're going to be diving into the world of MLOps.
Oh, yeah.
And
It's
specifically,
a good one.
we're going to be looking at professional certifications
Yeah.
in this field.
Nice.
Yeah.
MLOps is,
If you're out there and you're thinking about maybe getting a certification in this space,
yeah.
this is the episode for you because we're going to be talking all about what it could mean for your career.
Okay, so today I'm going to discuss about the MLOps. What is MLOps? From where it has, originated, evolution, some of the key concepts. What are the life cycles of MLOps? Uh, what are the workflows, and then some of the associated tools. So if you look at this MLOps, we have two keywords. One is ML, another is ops. Now ML stand for machine learnings, and then ops, if you remember, DevOps, ops has come from there. That means here we want to, just like DevOps has automated the software development lifecycle, and it has fetch lots of benefit, and we have already discussed about the DevOps in various sessions. So it we did the CI and CD in order to implement the DevOps. Something similar, MLOps is gaining momentum from last couple of years because popularity of AI, artificial intelligence, and then machine learning. So uh, there's a buzz around, like around us, like can we automate this as well? Can we, whatever the model development process we have, can we automate this as well? And that is where this keyword has become very popular in a recent few years. So yeah, here we have a uh, machine learnings. Let's try to define the machine learning first. So in this context of machine learnings, the machine refers to a computer system or algorithm designed to perform tasks that typically require human intelligence. So basically, a machine you can consider is like a compute unit where you have a certain algorithm, certain programs which you want to run in a different scenarios. And then second keyword what we have is learning. So whatever the programs which is run by a compute unit machine, what learnings you get it, that learnings we keep fine tuning based on the certain data, and that is called learning. So learning in a machine learning signifies the process of machine improving its performance on specific tasks through experience without being explicitly programmed. That means there are certain tasks which we have given to machine, and machine is doing the task in n number of times, and every times when they perform, they are also learning from their experience, the last multiple runs, and based on that they keep improving the systems, keep improving the data or performance or whatever it is, and without writing a more program. So that is called learning. So yeah, combining these two concepts, machine learning is the discipline within artificial intelligence AI that focuses on developing systems, machines that can autonomously learn from the data, that's called learning, to improve their performance on specific tasks without being explicitly programmed for every single outcome. So basically, this is one of the way to, where machine will write and do the program for us. So in essence, the machine learning is about enabling machine to learn from data without explicit programming, allowing them to improve their performance over time. So this is the machine learnings. In order to understand the MLOps, machine learning, we need to understand the machine learning very well. And if you want to trace the machine learning, that how it has come from and where it has come. So in order to do that, we have to understand the core branches of machine learnings. So now if you see that here, machine learning is one of the subset of artificial intelligence. So under the artificial intelligence, we have a many branches of artificial intelligence, such as machine learnings, language processing (NLP), expert system, vision, speech, planning, robotics, and few more actually. And let me tell you here, this is a growing domain actually. Lots of things which is getting added uh, as we study further. And then this is a growing domain, so lots of things will get added over the period of time. So right now, based on the branches which we have are popular in AI, these are the one of which is machine learning, and that is where we are trying to implement the MLOps. So yeah, machine learnings primarily. So AI has multiple branches, one of which is machine learning. So, but multiple machine learnings also has multiple branches. Okay, but these three branches are very popular. One of the branches we call it unsupervised learning, and second one is supervised learning, and third one is reinforcement learning. So these are the three most popular, though deep learning is also coming under the machine learnings, by the way. So again, I just said, like, this is a growing domain, lots of things which is coming on the way. So every couple of months I'll keep modifying these slides, so you will have up to date content on the LMS. Okay, so yeah, these are the three branches right now machine learnings has: supervised, unsupervised, and reinforcement learning. So all these three branches we'll discuss in some of the upcoming slides. So now if you look at this here, this slide is very interesting. Here you have a artificial intelligence, then machine learnings divided into three branches. And below the one which you are seeing here is these are the algorithm. Now, what is algorithm and how this is very important for the machine learning, that we need to understand. So that we'll discuss in upcoming slides. So these are the most popular algorithms which we have under the machine learning. So some of the algorithms you have to be comfortable. I must tell you, in MLOps you don't need to program for the algorithm, but you need to be comfortable with algorithms, KNN, linear, naive, and so many. Now, again, what is supervised, unsupervised, and reinforcement? We need to understand this. Okay, so what is supervised learnings? Supervised learning is one of the most commonly used branches of machine learnings, where the model is trained in the labeled data set. Now the question is, what is model? So this I have defined in the upcoming slides, but let me tell you here, when we say MLOps, basically I'll put it in this way. You have attended those classes. So DevOps, we develop a software, right? And then in order to increase the you know the uh, uh, reduce the cost, in order to reduce the cost or improve the quality and immediate feedback, immediate release, all this thing, we do the CI and CD, right? And for that, whatever the process and practice we follow is called DevOps. But in a machine learning world, AI world, we develop a model. Okay, not a software. Again, model is also is a software, but the difference between the software and the model is, like, software cannot learn self, whereas a model, it can learn and improve self. That is the difference, primary difference here. So model is trained on the labeled data set. That is important here. Supervised learning, is their models is being trained on labeled data sets. Okay, data which is labeled with. This means that for each input, the corresponding output is already known. Okay, allowing the model to learn by comparing its predictions with the actual outcomes. Supervised learning is particularly effective for tasks where objective is clear, such as classification and regression problem. By the way, classification is one of the algorithm types. Regression is also one of the algorithm types, which I'll come back on this. Now, this is one of the good image which I have on supervised learnings. If you look at this, there is a lots of data we have. Data in terms of, if you see that some of the objects we have tomato, carrot, and capsicum and all kind of things. And these all are labeled, right? So tomato is labeled with label called tomato. Carrot is labeled with carrot, and the capsicum is labeled with bell pepper, correct? So now what happens? You have a data along with a label. So basically supervised learnings works only on the label data. Okay. So structured data, you can also say in easy way. And then what happens? The data with the labels is feed into the model for training. And based on that, the model say, okay, these are the carrots, these are the tomato, whatever it is. And you have a tested data below. So that way, this is one of the easy way to predict what exactly carrot and bell pepper and tomato. So this is a supervised learning actually. One more example, if you see that here, input raw data tomato, and that has passed through algorithm. I'll talk about the algorithm in some time. An algorithm through some processing model, and then model got trained, and then that model is able to tell you whether this is tomato or not tomato, something like that. So here you have a labeled data, you have a definite data in this supervised learning in ML. This is one more example. If you see, these are all the data we have with the labeled cow, elephant, and camel, and then passes through the algorithm, process through the model, and the model is being trained, and then output is like which one is elephant, camel, and cow. This is just a example, and this is just for understanding the supervised learning. So the most important part of the uh, for the supervised learning branch in machine learning is the all the data you will process which is labeled, and that outcome is fixed. Outcome is fixed means you know that output it will be elephant only, or camel, or cow, because you have a tested data only three, right? So here outcome is fixed. So please remember that. But there is one more branches of machine learnings what you have is unsupervised learnings. Okay, so unsupervised learnings is used on the data which is not labeled. Okay, so here all the data, if you see that it's labeled, whether it's a cow, elephant, and camel, but unsupervised learnings is not labeled actually. So unsupervised learning is used when the data is not labeled, meaning that the algorithm must find patterns, groupings, or structure in the data on its own. So patterns like you will have to find a patterns. This algorithm will find a pattern or certain sort of groupings, or the structure is own structure actually they will find it. So this branch is essential for discovering hidden structure within the data. Okay, making it particularly useful for clustering, dimensionality reduction, and anomaly detection. Now this you can understand, you might have seen if you have worked with, let's say, Datadog or App Dynamics or Dynatrace or Elastic or Splunk, whatever it is. So in the log you might be seeing the pattern, right? You have millions of data, millions of logs, and out of that they detect the pattern. Have you seen this?
Yes, yes, yes. I
Yeah.
work on this.
So
Yes.
yeah. So that data, how that is coming. So there they have applied the unsupervised learnings where you don't have a data which is labeled, but it's a pattern or groups of the data, and that way they find out the output of it. So if you see that here, example, input raw data which is not labeled, and then you have a certain algorithms, and then process the data and output it can be here you have a groups. So output is like all the caps come, that's a red and green or whatever it is. So based on the structure. So unsupervised learning is a type of machine learning where algorithm learns from unlabeled data without any predefined output or target variable. Let me tell you here, here most important thing is algorithm. Whatever the algorithm you apply on the data, which is labeled or non-labeled, based on that you get output, and based on that training happens. So yeah, unlabeled data, and then you apply the algorithm, and then results you get it. Again, this is one of the good example for unsupervised learning in ML. You see that, and so on. Now the third branch of machine learning is reinforcement learning. Okay, so reinforcement learning, this is also called RL, is a branch where an agent learns to make decision by interacting with the environment to maximize the cumulative rewards. Now, if you want to understand this model, I mean this branch, then you can think of yourself. How do you learn, right? How do you learn? How a boy or girl or kids or baby learns over the period of time, right? So they have some environments, and they get the data, and based on that they make a mistake, sometime happy mistake, some mistake which is for the good out with a good output, and sometimes mistakes, I mean the some action which we should not call it a mistakes, action for the with a happy output, sometime action which is a not happy output. So whatever the happy output you get it, you repeat that activities, right? And that is how you learn. For example, let's say study is a good thing, so you study more and more, so you get a good output. And something is bad, so you don't do that, right? Based on the, let's say you are putting your fingers in the fire, so you get a pain, right? So outcome is a pain, so you don't do that again. You might have done in your uh, childhood days by mistake, and then you learned. So that is something called reinforcement learnings. Okay, so let's understand this. Here if you see that there is one agent, this agent, it can be you or human or animal or robots, compute unit also. An agent will do certain actions in certain environments. So environments will be there, certain environments like ecosystem, like you are also functioning in the ecosystem, I'm also functioning in a some ecosystem, right? Some house is there, and sky is there, all this thing is the environment, right? So agent will do some action in certain environments, and they get a rewards. The rewards can be in a positive and negative both way, and based on the rewards we will do those more actions. Okay, and then we'll keep observing, and the agent will keep learning throughout this whole process. The only difference is the agent which you have is a computer which is never sleeping. We are the person who sleeps for, let's say, 8 to 10 hours, but they will never rest. That is the difference, major difference. Okay,
Okay.
so here that is called reinforcement learning in ML. So again, you see that dog, which is the agent who's sitting. So state action, he started walking. And so here what agent will is learning, if you walk, if you sit, you get nothing. If you walk, you get a reward, some biscuits or something. So the agent will do more walking, and that is a learning. So that means agent has learned, if you sit you get nothing, but if you walk you get certain reward, some output, some result, some good one. So that is the way you keep train the agent in this visualization, you can say computer and some programs. Again, this is us, right, baby, which can be agent. And then if you want to teach them, so you have to if crawling, then you get some food, and if you're sitting you not get a food, something like that. Now there's so many algorithms again in machine learnings. Everything is all about the algorithms, so I'll discuss about that. Though we in this course you don't need to get into the algorithm because we are not writing a code and all, but we'll do the operations work, MLOps. Okay, but you need to know all this stuff. Again, see cat and stuff like that. One more example, something similar. One more example here for reinforcement learning in ML and so on. This is a little bit detailed way, but right now it's not important. So what we learned, we learn AI. I mean, machine learning is a part of subset of AI, artificial intelligence. By the way, artificial intelligence is huge actually, out of which machine learning is one of the set, one of the subset. And machine learning also has a multiple uh, I was reading today. It has a more than 10 branches right now, but as I said, like the world is becoming very, I mean, this domain is becoming very complex slowly. But for time being, we'll focus only on three most fundamental and important one: supervised, unsupervised, and reinforcement learnings. So
Okay.
here these are the difference. So what we learn in supervised and unsupervised learning, supervised learning, the data will be labeled one. Remember, the data will be labeled one. Unsupervised learning, data will be not labeled. Okay, so mind it, that is a major difference. These are some of the algorithm for supervised, unsupervised, and reinforcement learnings, and so on. Again, you see that learning through machine. So supervised, label data, you get a direct feedback, predict outcome failure. That means you can predict outcome and future. And here unsupervised one, no labels, data with the no labels, data with the no feedback, and find hidden structures. Reinforcement learnings, decision process, reward system, learn series of actions. Okay, now so we have understood these are the part of the uh, machine learnings. But what is the evolution of machine learnings? So these are some of the key dates which you have, though lots of data has come here. So these are some of the dates we have to start with, like 1957, where we got perceptron algorithm, then decision tree. Some of the more evolution has happened 1980, 1980s, and so on. So yeah, these are the one more visualizations of the same data and some more visualizations of evolution. So we are not, I mean, for knowledge you can just read it, but not is so important, and so on. Now the most important part of the machine learning is three things: data, algorithm, and models. And you need to know this one. Why? Because this is where you are going to work in order to automate it. Data, algorithms, and models. This is the part of the machine learning. So what is data, what is algorithm, and what is a model? So these are the three things combined together, and then it create a machine learning experience. So what are the data? So data can be as different types of data which you have, and numerical data we have, time series data you have, categorical data you have, some text-based data. So these are the data you have it. So you can use the data in data training data. You can use for validating the data and then testing the data. So some of the types of data you can see: images, it can be one data, text can be one data, speeches also can be one data, tabular it can be one data, and all this sort of data which you pass it through the models, algorithms and models, and then you get some information out of these images, text, speeches, and tabular. Okay, so these are the popular data types which we refer in the machine learnings: quantitative, one a branch, and then qualitative, one other branch. And then under the quantitative, you have a discrete and continuous. So what is a quantitative? So quantitative is like a data that can be measured with a number such as duration or speed. Qualitative data, non-numerical data, that is categorical, such as yes or no response or eye color or something like that. So quantitative also discrete and continuous. Discrete, the whole number that can't be broken down, such as the numbers of items, and continuous is like a numbers that can be broken down, such as height or weight. Again, continuous data also can be divided into two part: interval and ratio. Intervals like numbers with known differences between variables such as time, and then ratio, numbers that have measurable intervals where the difference can be determined, such as height and weight. Nominal data, which is the data used for naming variables such as hair colors and all. And ordinal data, data used to describe the order of values such as happy, one is equal to happy, two is equal to neutral, and stuff like that. So these are the fundamental data types which is used in the machine learnings. Again, different way to put it up: categorical, numerical, nominal, ordinal, interval, ratios, and all, and so on. Now next one is what is algorithm. So algorithm is very important player as in machine learning actually. So machine learning algorithm is a set of rules or procedures that a computer follow to learn from the data. So see, you have a data, but the question is how to read the data, and what to read the data, what to learn from the data, and that is written in the algorithm. So machine learning algorithm is a set of rules or procedures that a computer follows to learn from data. It is underlying mechanism that builds the model. Remember that. Model is built from where? Algorithm. Algorithm do what? Algorithm is running on the data. So data is important. Okay. So machine learning algorithms are a set of rules and statistical techniques used to perform specific tasks by learning from data. These algorithms are designed to identify patterns, relationship, or trends within a data set and use this information to make prediction, classifications, or decisions. They are building blocks of machine learning models. Okay, so again, these algorithms again is the same three types. Most popular one. Machine learning algorithm can be broadly categorized into three types based on the nature of the task they are designed to perform. Supervised learning, which I explained last time also, works on the labeled data. Unsupervised learnings works on the not labeled data, and reinforcements where we have a rewards and outcome and all this stuff. Okay, so these are the some of the algorithms and their abbreviations which is been used. Okay, so we have MLR, OLS, SGD, PCA, PCR. So many algorithms we have. These are the most popular. More than 300 algorithms we have, but some of the algorithms are most popular in the machine learning. So these are the one. Just you can read it. You need to remember because we'll not work on this. But yeah, just be comfortable with it. There are four. There are few more algorithms which you can see in these slides we have for the different um, things. Now this image is a very important one. Which algorithm will do what, and what exactly you get it from that. So basically, you can help yourself to find out from that. So here you see low to high in terms of accuracy and interpretability. So you can decide which algorithm is good and not good or something like that. Again, this is one of the little more comprehensive list of algorithm. Uh, um, Here you see that clustering, regression, decision tree, and so many algorithms we have. I mean, again, nowadays every week one algorithm is coming onto the machine learnings. People are developing and contributing to the GitHub or many other places. So, but these are the most popular algorithm which we know we have it. Okay, so these algorithms also, because the number of algorithm is growing a lot in a different domain. So these algorithms have also categorization. Like we started having the algorithm categories such as linear regression, logistic regression, ridge regression, and lasso regression, decision tree, random forests, gradient boosting regression, XGBoost, light GBM regression. So these are all the category which you see. Tree-based models and linear models is a part of supervised learnings. Okay, and unsupervised learnings, we have a k-means, hierarchical clustering, and Gaussian mixer models, a prior model. So many models, many algorithms we have it. So they have these are the most popular one, by the way. And if you have an interest, you can just spend some time to get into that. Okay, so more or less these are the some of the algorithms which we have. So we discuss about the data, and then we discuss about the algorithm, different types of algorithm, and popular algorithm, which I just try to make you comfortable with. So these are the algorithms which I have. Now, last one as part of the machine learning is model. What is model? So we know data and different types of data, and we know algorithm, different types of algorithm. So the models, a machine learning model is a mathematical representation of a real world process. Okay, it's created by training an algorithm on a data set. Remember that. Machine learning model is a mathematical representation of real world process. It is created by training an algorithm on a data sets. Once trained, the model can make prediction or a decision on a new unseen data. So I'll put it in this way. See here. Uh, let's say one baby is born. So how many years you give them a time to learn, study, play, and do all these things, and then ask for doing some jobs? Let's say 20 years, right now. So
Yes.
20 years is learning everything, and then he will qualify, he will pass, he will fail, he will get experience of our life, environment, and many things. And then he'll start working and make money for the family, something like that, right? So something similar, models also need to be trained, okay, with a certain data sets and with a certain algorithms. Model has to be trained, and models training, once the training is completed, then that models can be used to you can make use for a real work or decision on nuance in data as well, whatever that, to make it work. So what is MLOps, by the way? So I'll come back to that. But MLOps is basically, you know what, MLOps is one of the process in which you are helping the model training and deployment. Mind it, I'm saying model training and deployment in a continuous way. Remember that. In software development, what we do? Continuous integration and deployment. Here also we do the continuous model training and then continuous model deployment. Okay, so these are the two things we do as part of MLOps. Okay, so please remember that. So the only difference, model versus software, you have to remember that. So yeah, model, let's understand in this slide. In a machine learning, a model is a function that maps input data to output prediction. This function is learned from the data during the training process. And during training process, you need to speed up this process, because see, a kid can learn in 20 years without MLOps. Kids can learn in 2 years with MLOps. So if someone will ask you, what is the advantage of MLOps? So advantage of MLOps, your models can be trained and can be deployed faster. Simple. Answer is simple. Are you getting me right?
Yes, it's got it.
Yeah. So in a machine learning, a model is a function that maps input data to output predictions. This function is learned from the data during the training process, where the model adjusts its parameter to minimize errors in its predictions. Once trained, the model can be used to make predictions on new unseen data. So
Here you see that some of the representation which you have discussed in supervised and supervised as already. So model is being trained in middle, and then once the model is trained fully, then you can deploy to the real world scenarios. Okay, so here these are the process. Problem, you have to first define the problem statement, what kind of model you want to develop, and then you have to feed the data, then you have to pre-process the data, then you have to select the algorithm, and training will start happening, and this will run a number of times, a number of month, days, or whatever it is, and then evaluate whether the model is accomplished your task or not, and then see the output. So this is the model, machine learning's model. Again, if you see that one more visualizations of it, supervised learnings, unsupervised learnings, and then reinforcement learnings, and so on. Okay, so these are the phases. You see that data collections. Now, what are the tools we can have a data collections? I don't think so. I have to tell you because we have learned so many tools in the SRE and DevOps sessions which can collect the data. Most of the monitoring tools which you have worked with is capable of collecting the data. Data pre-processing, yes. Data splitting, selections of feature, model development, model evaluations, and so on. So these are the phases of model training. Again, these are some of the algorithms. I'll just skip it. Too many times we have discussed, and so on. So what is the difference between models and algorithm? So a model is an expression of an algorithm that identify hidden patterns or makes predictions. Algorithm, whereas we discussed, algorithm is a set of well-defined programs and instruction typically used to solve a complex problem or accomplish task. Something like this we have discussed already. So some of the use cases you want to understand about the machine learning types. So you can use in the house price prediction, you can use in the medical imaging, you can use in customer segmentations, you can use in market basket analysis, you can use in test classifications, lane finding on GPS data, optimize marketing and driver's list cars, and many more use cases. Some more comprehensive use cases you can find in this image. Okay, so now the most important part of the session, which is what is MLOps, right? What is MLOps? So what we call it, MLOps stand for machine learning operations. Okay, so DevOps, I think we know that, and if you missed that my DevOps videos, you can refer in the DevOps concept course in LMS, so you can check that. So here what we did, machine learnings with the DevOps, simple. Okay, so whatever the machine learnings in what? Developing the model, training the model, and deploying the model, right? So how this process can be do faster using the DevOps concept, that is called MLOps. Okay, so MLOps, machine learning operation, is a set of practice. Mind it, DevOps was also practice, principles, and tools. Same way, MLOps also set of practices, principles, and tools designed to automate. Mind it, automate, streamline the end-to-end life cycle of machine learning model in production. Yes. MLOps combines the discipline of machine learning and operations to ensure that machine learning models are developed, deployed, monitored, and maintained efficiently and effectively. I just stated, DevOps will do what? Software development, software developed, deployed, monitored, and maintained efficiently and effectively. Whereas in MLOps, models are developed, deployed, monitored, and maintained efficiently and effectively. Are you understanding?
Yes.
Yeah.
Yes.
So
Yes.
please remember that. And how can we do speed up? How can we reduce the cost? How can we deploy faster and better way? How can we maintain the quality? For that, we need a operations concept. Okay. So yeah, machine learning, DevOps, and data engineering all is coming. All this basket is coming under the MLOps. Okay. So in machine learning, what do we do? ML model development, In data, what we do, data engineering, what we do, process the data,
Process the data.
collect the data, index the data, clean the data,
Hmm.
parse the data,
Yes.
all these things we do that, structure
All
the
the
data,
EDA process
non-structure.
will do. Yeah,
Right, yeah.
structure.
So many
ETL.
tools we, yeah, so many tools we have, and then we train and deploy through the CI/CD DevOps process. Many multiple tools you have already spent some time on that.
Hmm.
Okay,
Yes.
so these are the three things. So model developments, what it will include, building the model and CI/CD pipeline. So first you do the design, drafting models and data management. After that, you do the model development, which is the building the model and CI/CD pipeline. And now after that, deploy the model and manage and monitor and scale the model operations. So these are the three things which is coming under the MLOps. So machine learning's operations, which include ML design, ML model development, and operations. So you need to know everything, but most of the work will be there in the operations only. Okay. So ML design, which include gathering requirements, what kind of model you want to design, prioritize the ML use cases, business understanding, and data acquisition from where you get the data. Remember that to develop a model, you needed data. I think you might be hearing nowadays many things actually. Data is a new oil, right? Everyone is talking about. In fact, Prime Minister Modi has spoken last month. Data is a new oil, right? So data is everything. So from the data, you can create a model, and model can be deployed, and deployed model can do a lot of things, work which you cannot do that. You will do slow, something like that. So yeah, these are the ML design, and then model development will start, data preparation and processing, feature engineering, model training, experimentation. Model training will happen with the help of algorithm. Remember some of the algorithm which I showed you, a hell lot of algorithm. I just stated there is a registry for algorithm itself. Thousands of algorithm has come so far, and it's growing actually every day, every week. And the model analysis and evaluation. After that, once it's done, then you deploy for the real work. So ML model deployment, CI/CD pipeline, all this thing we do, model monitoring and triggering. Okay, so what is that evolution of MLOps then? So MLOps is just a recently buzzword around 2000 onwards. So not much history, because just it has come after the DevOps. Everyone started talking about the DevOps, then MLOps also has come. So yeah, from the 2000 onwards, some buzz has around and so on. Now, some of the most important development you can see that in the MLOps world actually, a lot of product has been designed so far. Some of these we are using actually ChatGPT, at least we are using that one, who's learning every day and night automatically, right, from you, and so on. Now, if you want to see the domain, how it will perform, so look at the some of the prediction which was done by market.us. I just found on the Google and found out useful, so just put it up here. And here you see that $75 billion market market. You see that business aspects we have for the MLOps actually. Now, if you look at the Google trend, this is the screenshot of the Google trends. Okay, MLOps keyword, how it is gaining the momentum. So if you look at this, it is gaining the momentum just after 2020, I guess somewhere, and after that they started getting the momentum. So you see that the growth has come in last couple of years, couple of months, I would say, more actually. If you see 2021 onwards, you have a more growth actually. Okay, so what are the key component of MLOps? So yeah, one of the important component is collaboration and communication, because it's all about the ops, and ops means communication, integration is important. So collaboration and communication between the teams, mind it, teams. Many teams are there as part of it, and the teams which includes like data scientist. Now you need to work with the data scientist also, and then machine learning engineers, software developer, and IT operations. They need to communicate and collaborate in order to set up MLOps. Then you need to set up a CI. Now you have developed a CI already using some of the tools for the software. Now you have to develop for model MLOps. and CD part, and then version control. Version control, I think that is, we understand that Git and all kind of thing stuff, so we do that. Automated testing, so we understand that monitoring and performance management, scalability. Nowadays, I think you know that Kubernetes, so you don't worry about that. Security and compliance is one of the things which is part of the DevSecOps, but as a part of the MLOps. So these are some of the key components if you really want to implement the MLOps. Now, let's say if you want to implement the MLOps like automated collaboration, communication, CI, CD, version control, automated testing, and monitoring, scalability, and all. So there must be some tools, right, which you need to know in order to implement that. So these are some of the tools which I have mentioned here. Some of the tools you may be using, some of the tools we have covered in the Git DevOps training and SRE also, and some of the tools which I'll teach you. No, but not every tools you need to learn, because you cannot be a data scientist, right? Your primary role right now, you are playing somewhere is machine learning's engineer. This is the one who will be working on the integration part and IT operations team, something like that. Okay. So yeah, some of the tools which you should know, like working with the Slack for Jira, Confluence. This for the collaboration and communications. For CI tools, I think go for the hosted one. Let's say GitHub, GitLab CI, or GitHub also we have it. CD part, we have so many tools actually, so you can use it. Version control, I think you are already pro. Git is a most important one. But you know what? MLflow has a built-in versioning, model versioning concept, so that also can be used. DVC now no one is using nowadays. Automated testing, we have certain tools we have for that. Model testing, so MLflow can be used for model testing also. Monitoring and performance management, we have many tools, Prometheus and Grafana. MLflow can be used for model monitoring also, so like that. Scalability, like a compute you need for training the model, right? So Kubernetes, Docker, and all, it's good for it. Kubeflow for the you know functionless. So all these things you can use it. Security compliance, some of the tools we have for that. Experiment tracking, we have again few tools. Data management, we have Airflow is the most important one, um, which is very popular for data pipelines. Model deployments, we have again many tools. Most of the deployments we do in the AWS, so that is also TensorFlow also serving is being used. Uh, uh, and model maintenance and rate training, some of the tools we have. Orchestration, Airflow, again we have. Apache Airflow is a major tools actually in this. So some of the tools is very important, like MLflow, Apache Airflow, and here we have yeah, uh, and also the other tools very important. Okay, so any questions so far?
No, I understood.
Yeah. So some of the benefit of MLOps, which will help you to increase efficiencies, improved collaborations. When I say efficiencies, again, in order to develop a model, train a model, you want to work with multiple teams, right? So this will help you to improve the efficiencies, collaborations, and you can improve the quality of your model with the MLOps. So if someone will ask you, hey, what about if I don't follow the MLOps? Then you can say the quality of the model, uh, what you get with the MLOps compared to the without MLOps, it's a huge difference actually. So you can increase the quality and all. Scalability, reproducibility, reduce time to market, all this thing you have with MLOps. Again, whatever the advantage we had with the DevOps, same thing with MLOps as well. Okay, so how do we start working with it? This sections I'll go a little fast, so you'll understand that MLOps life cycle. So first thing what you have to do. So first thing, data collections. Second thing, data preparation. Third thing, model experimentations. Fourth thing, data pipeline and feature engineering. Then fifth thing, building a model. Sixth thing, evaluating the model. Then seventh thing, deploying the model and then maintaining it. So most of the time, you will be involved with monitoring, deployment, and evaluation phase. Sorry, and sometimes data preparations also, data collections also sometimes. Okay, so here 4 pillars. You have data, collect, curate, transform, validate with apply the model, explore the which algorithm you want to apply, train, evaluate whether it's good or not, and then formulate, and then after that develop that model, code, build, test, and release, and then followed by last operations, deploy, operate, and monitor. I think this is the one of the best slides which you can understand the MLOps in all phases actually. Okay, again, same thing, collect, curate, transform, validate with the data, train, evaluate, and formulate with the model. And after that, develop that model in terms of planning, code, build, plan, code, build, test. And after that, operations, deploy the model, operate, and monitor it. So that's a complete flow. Again, this is a good image. More or less we have discussed. So I'll just ignore it and so on. Okay, so these are the major uh, phases which you have in the workflow: model development, validation, deployment, monitoring, and maintenance. Okay, so how do we get started? Let's say you want to do end-to-end thing. It's not like only MLOps, but end-to-end thing. So first thing, you have to define what kind of model you want to create. So have a model problem definitions. Okay, clearly define the business problem that the machine learning model is intended to solve. Okay, that's the first thing. Second thing, after that, once you have a problem statement clear, then gather the necessary data from various sources to train and evaluate the model. Data is important, right? And after that, clean and pre-process the data to make it suitable for modeling. Fourth one, exploratory data analysis EDA. Explore the data to understand its distribution, patterns, and relationship. This you'll do with lots of algorithm actually. After that, feature engineering. After that, you have to enhance the dataset by creating a new features or selecting the most relevant ones. After that, you decide that whether you have got the proper model or not. To choose the appropriate machine learning model based on the problem and data characteristics, whether it's aligned with your requirement or not. After that, you train the model. So train the select a model on the training data set to learn from the data. After that, validate the model. So validate the model performance using validation dataset and tune hyper parameters. And then evaluate the model whether it's matching with your. So evaluate the final model on a test dataset to ensure it generalizes well to new data. And once the data is evaluated, then you do the tuning, hyper parameter tuning. Optimize the model by fine tuning hyper parameters and then start deploying the model. So deploy the trained model to production environment where it can we can make real time or batch prediction. And after that, you have to start monitoring and maintenance that environment. Continuously monitor the model's performance in a production and ensure it remain effective. Okay, and after that, keep reevaluations and updating it. And then at certain times in the future, you may have to retire the model if something new has come up and so on. So this is the complete phases. Now for each stages, you want to know that some of the tools I want to learn. Okay, so problem definition phases, some tools which can be helpful: Jira, Confluence. Asana also is being very popular nowadays. Data collections, Kafka we have, NiFi we have, S3 we have it. By the way, lots of agent also can be used for data collections. If you want to pre-processing, Pandas we have, Spark we have, Databricks we have, but small tools like Logstash we have, and so on. Exploratory data analysis EDA, Jupyter notebooks, Matplotlibs, and Tableau. Feature engineering we have some of the tools, and model selections we have some of the tools like scikit-learn, TensorFlow, PyTorch, Torch. Model training we have TensorFlow, PyTorch, XGBoost. So some of the tools which we are already covering in the session, for example, TensorFlow I think, and then PyTorch already there. Skitty also I think is there. I have to check. Model training, we have TensorFlow, PyTorch, XGBoost. Validation, we have few tools. Evaluation, we have some tools. Hyperparameter tuning, we have some tools. Deployment, again, we have few tools, AWS SageMaker, TensorFlow and all. Monitoring and maintenance, we have few tools. Model revaluations, we have some tools, and so on. So yeah, these are the tools. Now some of the roles people in MLOps. So I think what kind of role you will be playing, again, depends whether you are a data scientist or ML engineers or data engineers or DevOps guy or some security expert. So these are the most popular roles which you have in the MLOps domain. Okay, so data scientist, machine learning engineers, DevOps, data engineers, software engineers, and these are some of the key responsibilities of the each roles which you have. But so more or less, I think if you are working in this domain, you will be working on the machine learning engineer, which will do the model deployment, model optimization and scalability, integration with the production system, and monitoring and maintenance. So these are the things you have to focus on more for that. Okay, some of the more roles: IT operations, project manager, business analyst, data analyst, security engineer, and so on, and respective key responsibility. Okay, so this is the MLOps. So now, did you understand what is MLOps and how we should get started?
Yes, yes. Actually, my role is I deal with machine learning algorithms and big data. So this MLOps, okay, it will touch ML. I mean, the DevOps part. I got it. I understood. Yeah.
Yeah. So if you are, see, these are the roles we have. So I'm not sure, but yeah, I just guessed it. Maybe data engineer or maybe machine learning engineer. So machine learning engineers, your DevOps learnings will help you a lot. Data engineers, again, ETL side and many other stuff.
Yeah, yeah, got it.